So today we are looking at the estimation of glucose concentration in a sample using the Folin Wu method. We'll start by looking at what the Folin Wu method is. So the Folin Wu method is an assay which is used to quantify the amount of glucose in a sample. And one key glassware or important glassware that is normally used in the Folin Wu assay is the Folin Wu tube. The Folin Wu tube is a glass test tube with a constricted portion or neck. So as you can see over here, this is our Folin Wu tube with a constricted portion or neck over here, and with a bulb-like structure at the bottom. So as you can see over here, this is the bulb-like structure at the bottom, and markings at 12.5 mils and 25 mil. So these are the markings at 12.5 mils and 25 mils over here. And the importance of the Folin Wu tube is to prevent the reoxidation of cuprous oxide by atmospheric oxygen. And what we also have to notice that in the Folin Wu assay, there are two main reagents that are normally used. And these are the alkaline copper tartrate reagent and phosphomolybdic acid. The alkaline copper tartrate reagent, it's basically a mixture of anhydrous sodium carbonate, tartaric acid, and copper sulfate in their required masses with distilled water. So let us look at the importance of the alkaline copper tartrate in the Folin Wu assay. One is that the sodium carbonate provides an alkaline pH medium for the reaction, and the copper sulfate makes available the cupric ions for reduction to cuprous oxide, and the tartrate, which is a derivative of the tartaric acid, helps to chelate the cupric ions and releases it slowly for reduction to cuprous oxide. And the importance of the phosphomolybdic acid is to react with the cuprous oxide to form phosphomolybdenum blue. Let us look at the test principle behind the Folin Wu assay. The test principle states that glucose and other reducing substances at higher temperature under alkaline conditions will reduce cupric ions to cuprous oxide. The cuprous oxide formed then reacts with the phosphomolybdic acid and reduced it to phosphomolybdenum oxide or phosphomolybdious acid or molybdenum blue, which is a blue solution. And the intensity of this blue solution is a measure of the glucose concentration present. And this is the chemical equation explaining the test principle for the Folin Wu assay. We also have four main factors that affect Folin Wu assay. So the first is temperature. So the second is the pH or the alkalinity. The third is the heating time or the duration for heating, and the fourth is the concentration of the reducing sugar present. Let us now look at the Folin Wu method. In the Folin Wu method, we normally pipette 1 ml of our sample into a Folin Wu tube. Then we add 2 ml of alkaline copper tartrate and place in a boiling water bath for 8 minutes. After that, we cool under running water to room temperature. Then we add 2 ml of phospholipid acid and gently mix. And finally, we make up to the 25 ml with distilled water and mix gently and measure and record the absorbance at 580 nanometer. Some key observation in the Folin Wu assay. So let's look at the first one. Addition of the alkaline copper tartrate to your test sample. So all samples stem from colorless to light blue, and 8 minutes of boiling or heating. So what happens is that samples turn from light blue to brick red with increasing concentrations. And finally, the addition of phospholipid acid to the test sample changes color from brick red to deep blue with increasing concentrations. So let us use the Folin Wu method to prepare a calibration curve of concentration 0.0 to 2.0 milligrams per ml in 6 Folin Wu tube from a standard glucose of 10 milligrams per ml. So first of all, what we have to do is to set up a well-labeled 6 Folin Wu test tube, and the next step is to prepare a series of dilution of concentration ranging from 0.0 to 2.0 milligrams per ml in 6 test tubes. So thus we are going to prepare 0.0 milligrams per ml, 0.4 milligrams per ml, 0.8 milligrams per ml, 1.2 milligrams per ml, 1.6, and 2.0 milligrams per ml from the 10 milligrams per ml glucose standard that we have. So let's see how to prepare these various concentration from our standard glucose given. So example, using the direct dilution to prepare a final volume of 5 ml. So that is our fan V2 will be 5 ml for each of the concentrations here from the standard 10 milligrams per ml. So let us look at how to prepare the first concentration, which is 0.0 milligrams per ml. So basically, we are going to use the equation C1V1 equals C2V2. So where C1 is the standard concentration, so which is the 10 milligrams per ml, C2 is the final concentration that we are going to prepare here, which is 0.0 milligrams per ml. V2 is the final volume, so which is 5 ml from the example over here, and V1 happens to be the volume of the standard that is needed to prepare the final concentration of 0.0 milligrams per ml. So if you have to make V1 the subject, we have V1 equals C2 V2 all divided by C1, and if you have to substitute the various values into the equation, we will get V1 to be equal to 0 ml. The next is 0.4 milligrams per ml, and also we are going to use the same equation C1 V1 equals C2 V2, where the C1 happens to be the standard concentration 10 milligrams per ml, C2 the final volume, and over here, so the final volume, the final concentration will be 0.4 milligrams per ml. V2 is the final volume at 5 ml, and V1 volume of standard needed to prepare the final concentration. So making V1 the subject and substituting in the values that we have over here, we have V1 to be 0.2 ml. For 0.8 milligrams per ml, we will have our V1 to be 0.4 ml. And for 1.2 milligrams per ml, we will have our V1 to be 0.6 ml. for 1.6 milligrams per ml, we will have our V1 to be 0.8 mils, and our 2.0 milligrams per ml, we will have our V1 to be 1.0 mils. So from this table, what it means is that to prepare these various concentrations, we need the volume of glucose of the standard here and the volume of water in mils to be added to. So what it means is that to prepare 0.0 milligrams per ml, we need 0.0 mils of the standard glucose and we add 5 mils of distilled water to it. To prepare 0.4 milligrams per ml, we will pipette 0.2 mils of our standard glucose and add it to 4.8 mils of distilled water. To prepare 0.8 milligrams per ml, we will pipette 0.4 mils of our standard glucose and we add 4.6 mils of distilled water to it. To prepare 0.6 mils, to prepare 1.2 milligrams per ml, we add 0.6 mils of our standard glucose and we add 4.4 mils of distilled water to it. To prepare 1.6 milligrams per ml, we add 0.8 mils to 4.2 mils of water, and to prepare 2.0 milligrams per ml, we add 1 mil of the standard glucose to 4 mils of distilled water. So after doing that, we pipette 1 mil of each diluted sample into their respective Folin Wu tube. Then we add 2 mils of alkaline copper tartrate and place in a boiling water bath for 8 minutes and cool under running water to room temperature. And what we also have to note, and as explained earlier, the alkaline copper tartrate makes available the cupric ions and makes the medium alkaline, and the temperature aids to facilitate the reaction. So after that, we add 2 mils of phospholipid acid to it and gently mix. And what you also have to note is that the phospholipid acid reacts with the cuprous oxide to form phospholmolybdenum blue or molybdenum blue or phospholmolybdenous acid. So the next is to make up to the 25 ml mark with distilled water and mix, and the next step is to measure and record the absorbance at 580 nanometer. So this is our assumed table of results. So as you can see over here, we have our 6 test tubes labeled 1 to 6, and we have our glucose concentration being prepared over here, 0.0 to 2.0 milligrams per ml, and these are their respective absorbances obtained after subjecting them to the Folin Wu assay. So we can see that for 0.0 milligrams, we had 0.00 absorbance. For the 0.4 milligrams per ml, we have 0.412 absorbance. For 0.8 milligrams per ml, we have 0.802 absorbance. So for 1.2 milligrams per ml, we have an absorbance value of 1.227. For the 1.6 milligrams per ml, we have an absorbance value of 1.763. And for the 2.0 milligrams per ml, we have an absorbance value of 1.996. So the next is to plot these values to obtain a calibration curve. And to plot a calibration curve, we always plot the we will always plot the absorbance on the y-axis against the known concentrations on the s-axis. So these are our absorbances, and this is our the concentration on the s-axis. So as you can see over here, we plot the values for the absorbances on the y-axis, and this is our glucose concentration over here on the s-axis. So after plotting this, we try to find the line of equation, or the equation of the line for the graph. So from this graph, the equation of the line is giving us y equals 1.0331s and the r square value giving us 0.9941 over here. And what it also means is that the y over here happens to be our absorbance value, the 1.0331 happens to be our slope, and the s happens to be our concentration. Thank you.